Welcome to this explainer. Okay, look around you right now. The conveniences of our modern life, the devices we're constantly on, the packaging we rely on, even the energy powering our homes, they all cast a shadow, and we rarely see it until it's literally too late. Today, we are diving deep into the stark realities of modern pollution. But hey, don't worry. We aren't just going to sit here and look at the devastation. We're going to explore the real structured solutions that scientists, governments, and industries are actually developing right now to regain control of our planet's health.
So here's our roadmap for this explainer. We'll start with the many faces of pollution, then hit the plastic problem, tackling electronic waste, rating industrial pollution, and finally wrap up with some really innovative cleanup solutions. Let's get into it.
Okay, let's dive into this. Part 1. The many faces of pollution.
You know, when we hear the word pollution, it's super easy to just picture a giant smokestack or a littered highway. But the truth is, the threats impacting our globe are incredibly diverse. They're visceral and, honestly, often microscopic. To really understand how to manage waste, we've got to define exactly what it is we're fighting. We have to establish a baseline. So let's start with solid waste. Now, this encompasses discarded, abandoned, or just waste-like materials from industrial, commercial, mining, and agricultural operations. But here is the absolutely crucial part. It strictly excludes solid or dissolved materials in domestic sewage or irrigation return flows. Why? Because regulatory bodies need to know exactly what category of contamination they're dealing with before they figure out how to dispose of it, whether that's through landfills, incineration, or composting.
But, you see, waste isn't always something you can just hold in your hand. Look at this number right here, a pH of less than 5.6. That is the chemical threshold for acid rain. Basically what happens is that oxides of sulfur and nitrogen, which are very often pumped into the air by human activity, react with the atmospheric moisture up there. And when this highly acidified water falls back down to Earth, it causes absolutely devastating damage to our lakes, our streams, our forests, and the really delicate ecosystems of plants and animals that rely on them to survive. And sometimes, pollution is literally just a matter of temperature. Thermal pollution is this unnatural rise or fall in the temperature of a natural aquatic environment. So how does this actually happen? Well, fossil fuel power plants and big industrial facilities dump massive amounts of hot water they use for cooling, directly back into our lakes and rivers. It's crazy, but even just cutting down the trees and vegetation that naturally shade our streams, or allowing soil erosion to change the water's dynamics, allows sunlight to drastically raise those water temperatures. This seemingly invisible change, it completely disrupts aquatic life. It just throws the whole system out of whack.
Moving on to part 2. The plastic problem. So that covers some of the broader elemental changes happening to our environment. Now we're going to turn to a very specific material that totally defined the 20th century. Hailed as this wonderful invention because it was cheap and convenient, plastic has tragically morphed into an absolute environmental catastrophe. And the root cause of this whole hazard? It's our modern throwaway culture. But the consequences aren't just messy. They are chillingly biological. Conventional plastics pose severe, real-world risks right from the moment they're manufactured. For instance, burning plastics, especially PVC, releases furan and these highly carcinogenic dioxins straight into the atmosphere. And shockingly, dioxin is a toxic byproduct that is actually believed to be passed on through breast milk to nursing infants. So yeah, this isn't just about littered streets, right? It is a fundamental threat to human and wildlife biology alike.
So the crucial point is how this throwaway culture interacts with our planet's geography. I mean, think about it. Our marine resources cover 70% of the Earth's surface. 70%. They act as a key asset in our whole biosphere. Nearly half of global primary production happens right there in the upper layers of seawater. And seafood represents a whopping 20% of the protein in the entire global diet. When plastic pollution enters this space, it interferes directly with the delicate plankton species that form the literal foundation of this massive, vital food web.
And this brilliantly illustrates the differing yet equally devastating fates of plastic debris based purely on where it ends up. In the marine environment, the UV degradation of floating plastic is just incredibly slow, and retrieval or recycling, it's practically impossible. Once it's out there, it's out there. But on land, the problem is different, though just as severe. Uncollected plastics choke up city drainage systems, which causes waterborne diseases. They act like this giant, impervious plastic wrap that stops groundwater from recharging, and they leach toxic dyes and flame retardants directly into our soil. All right, let's jump into part 3, tackling electronic waste.
Now, as heavy as all those realities are, we definitely aren't without strategies. It's time to pivot gracefully from the crisis phase to the control phase.
As our reliance on technology has completely skyrocketed over the last few decades, so has our electronic waste, obviously. But globally, society is organizing a structured counterattack to manage the life cycle of all our devices. Instead of a straight linear path from the factory straight to the landfill, nations are trying to close the loop. Take a look at this. China has set a concrete target to use 35% secondary raw materials in the manufacturing of new products by the year 2030. That is a massive shift in outlook. It's about viewing discarded electronics not as trash, but as a seriously critical source of future materials.
But to actually achieve that kind of circular economy for e-waste, we need specific strategies. The ICEA report outlines 5 key steps to make this happen. First up, public-private partnerships. We need these to share the heavy financial costs of setting up reverse supply chains. Second, an auditable database. Basically, we need transparent tracking of materials so we know where things are going. Third is creating geographical clusters to make dismantling way more optimized and efficient. Fourth, we need to incentivize high-yield recycling centers. There is immense value trapped in our old tech, like rare earth metals from semiconductors, that we need to extract. And fifth, we need to promote product longevity by actually supporting a user's right to repair their own devices. Make things last longer, right?
Which brings us to Part 4, Rating Industrial Pollution.
So far, we've looked at the products we discard. Now, let's shift gears and look at the factories that actually make them. A really major part of controlling pollution is simply removing the ambiguity around exactly who is polluting and how much they're polluting. To tackle this, the Ministry of Environment, Forest and Climate Change developed a frankly brilliant scientific metric called the Pollution Index, or PI. It generates a clean score from 0 to 100 for any industrial sector. And this score isn't just some arbitrary number. It's a direct function of a facility's air emissions, their water effluents, hazardous waste generation, and their overall resource consumption. Basically, the higher the number, the heavier the pollution load. Simple as that.
And this pollution index feeds directly into a really intuitive color-coded categorization system: red, orange, green, and white. This grid totally removes regulatory guesswork. If an industry is highly polluting, it gets slapped with a red tag and is strictly banned from setting up in ecologically fragile or protected areas. But on the flip side, the white category is for practically non-polluting industries, and the system actively incentivizes these white industries by waiving the need for environmental clearance. That lack of red tape makes it so much easier for them to secure financing from lending institutions. It's a great carrot and stick approach.
But it goes beyond just rating large factories. There are amazing local initiatives too, like waste minimization circles, which basically empower small and medium industrial clusters to reduce waste right in their own plants. Backed by the World Bank, this initiative also places a huge focus on educating citizens on the economic and health risks. It recognizes a super powerful truth. Vigilant citizens and non-governmental organizations play a highly cost-effective role in monitoring the environment and supplementing the official regulatory systems. We're all in this together, essentially.
Finally, we arrive at Part 5, Innovative Cleanup Solutions.
Okay, so we have better manufacturing guidelines, we're building circular economies, and we have vigilant citizens. But what about the pollution that is literally already out there? Well, before we look to the future of biological science, it's worth taking a quick uplifting breather to look at our history of awareness. Did you know that Wildlife Week has been celebrated in the first week of October since the inception of the National Zoological Park, all the way back in 1957? It's true. Creating sympathy and awareness for nature isn't some new trend, it's been a recognized necessity for decades.
Now, awareness is obviously the first step, but action has to be the second. And that leads us to a fascinating question for you. Can nature itself actually help clean up the massive mess that human industry has created? Well, the answer to that lies in the microscopic world.
Now, what's really interesting about this slide is the concept of bioremediation. This is the deliberate use of microorganisms, specifically things like bacteria and fungi, to literally eat pollution, degrading environmental contaminants into much less toxic forms. It's like a giant biological cleanup crew. Scientists can either use microbes that are already indigenous to a contaminated area, or they can isolate very specific strains from somewhere else and deploy them directly to a polluted site to just start eating away at the problem.
Now, as incredible as that sounds, and it is incredible, it's important to look at this objectively. Bioremediation does have some distinct scientific hurdles. First off, it is strictly limited to compounds that are actually biodegradable. Not everything can be rapidly broken down by a microbe, right? Furthermore, biological processes are highly specific to certain contaminants. Plus, it is notoriously difficult to scale these operations from a small laboratory pilot to a massive real-world field site. And lastly, it generally takes a lot longer than your traditional chemical or physical treatment processes. So it's a powerful tool, but it's not a magic wand.
And that brings us to the end of today's explainer. We've seen the systemic threats we face, from the devastation of acid rain to the sheer scale of throwing away plastic. But crucially, we've also seen the incredible systems being designed to fight back, from China's aggressive raw material targets to smart pollution indexes, all the way to pollution-eating bacteria. The macro systems are shifting, which is great news. So I want to leave you with a final thought. As industries adopt circular economies and scientists deploy microscopic fungi to clean up our soil, what active role will you play in minimizing the waste of tomorrow? Think about your own environmental impact, and let that curiosity guide your next steps. Thanks for hanging out with us.